My name is Pavlo, as you can see. I'm 26, originally from Ukraine, and I am a backend engineer in the NordTech. And as you can see, I will talk about the tests today. And the first thing I want to talk about is the title. Exactly on the day when I was asked whenever I want to do the talk in this meetup, I had a technical screening. Technical screening is the first technical interview in our hiring process. That's where we asked the candidates about about their background, experience, pure technical stuff, like 30 minutes before we invite them to the live coding session. It was a nice technical screening. We had a nice talk with a nice candidate, and it was almost over. And then I asked my favorite question about the testing. And the first thesis that I heard from the candidate was, tests are useless. Tests are for testers. And after that, I had to ask for a quick break, so I had some time to cry. And after that, we still had some time left. And I tried to ask that person, like, why do you think this way? Because in my head, it sounds just crazy. Of course, we all know that tests are not useless. And you see, like, the half of you write the tests. Some of you even practice test-driven development. So what's the whole point of this presentation? Why should I talk about such obvious stuff? I thought whenever I should give a talk on this topic or choose something else, because it's just obvious. But you heard the example about the candidates, and I have at least one more. 2 years ago, when I was looking for a job, I was rejected by one company because I said I wouldn't accept a merge request without a test. And later I found out that their test coverage was something around 0, and they thought I wouldn't integrate in their environment. So not only we have the companies that still shift the code to the production without the tests, we also have people, and I clearly see during all the interviews that I have, that there are people who don't know a clear difference between unit test and integration test and when to use what. They are not familiar and never heard of testing pyramid. So, somehow we don't ask people the questions during interviews like, do you know how to use IDE, or you write everything in notes or on paper or something? No. But we still ask people whenever they're familiar with the tests. And by giving this talk, I want to remind everyone, including myself, why do we have tests in the first place, what are the good tests, and why they're your best friends. So this is the agenda. I will talk about how exactly are the tests not useless, what does a good test look like, what to read on this topic, because obviously, it's like 20 minutes presentation. I can't cover everything. And if you wanna learn more about it, I will recommend some books, and we'll have like maybe 10 minutes Q&A so we can all discuss our experience and maybe some questions about the presentation and so on. So let's begin. How exactly are the tests not useless? Let's get to the business. And here we need to take a step back before diving into testing and talk about why do we have tests in the first place? What's the return of time invested into writing the tests? What's the goal of testing? And the goal of testing is to enable a sustainable growth of the software project. And a word sustainable is the key. It's kind of possible to enable the growth of the project, especially if you start at the beginning, you started from scratch. But it becomes harder to enable this sustainable growth over time without the tests. And let's have a look at this diagram. Let's imagine that we start working on the completely new projects and we decide not to write the tests. I mean, who needs a test, right? Tests are useless. So POs are happy that we don't spend time on this thing that's called testing. And how would our life look like? Well, we take a task, we implement the feature. Maybe we test it manually, maybe not, who knows, like, who needs a test? And we ship it to production, next one. So we take next ticket, we implement the feature, maybe we test it manually, maybe we test the feature that we implemented yesterday, who knows, tests are for testers, and we put it to production. Can you imagine how this project would look like in 6 months, in 1 year? Will you be able to deliver the features just as fast as you were doing at the beginning, or will you be able to deliver any features at all? And that's where the tests come into the game. Every time you change your code base, every time you add the feature to your project, you increase the complexity of the code and the amount of disorder. Basically, you create a more place for bugs. And tests, if we have like good set of tests, they help us to make sure that after changing the code, after adding the features, the remaining functionality still works. And if you leave the project without the proper care, like constant cleaning and refactoring and so on, you will end up at a very bad situation. So tests work as a safety net, like a tool that can help you to enable the sustainable growth of the project. To keep our project clean, we will need to do some refactoring for sure. And I assume most of you read the refactoring book by Martin Fowler. And if you haven't done so yet, I encourage you to do it even now, because it's an amazing book. Everyone should read it. And Martin Fowler himself says, whenever I do refactoring, the first step is always the same. I need to ensure I have a solid set of tests for that section of code. And I don't know what your flow of refactoring looks like, but whenever I need to do some refactoring, I first make sure I have a solid set of tests for that method or class or module that I have to refactor. I run the test, I see it's green, hopefully, and I do some refactoring, and it's important that you do small changes and that you run your tests after each small change, even if it's just renaming the variable, so that if you made a mistake somewhere, you would kind of reduce the amount of the code of changes that you need to analyze if you made a mistake. Because we all make mistakes, right? We are just humans. And that's not the talk about refactoring, but we will definitely need the tests for it. And that's the basics. Can comments lie? Can documentation lie? For sure. But code never lies. And as Uncle Bob says, that truth can only be found in one place, the code. And I do agree with him on this point. Tests is a very good source of documentation. Whenever you integrate a third-party library, and we do it a lot nowadays, you will be very lucky if you just open the README or any kind of documentation, and you will find the code examples that you need, and that it will be enough and understandable for you. But if you don't, you can just open the tests and you will see all the code examples that you need, like how to create the object, what kind of exceptions are thrown, and so on. And recently I contributed to the open source project. It was like some kind of middleware for cross-origin requests. And so I created a set of tests, I created implementation, and then I adjusted the README. That's what it looked like. So I had to add the wildcards for the existing. I added this example to the README, and it would be enough if you are familiar with wildcards and you know how to use it. But what if I have no idea what is that? That example would be enough for me. Where would I look for that? Of course, in the tests. Look, here you have all the examples that you can, what you can use, what you can't use. And whenever I do the code review, the first thing is, of course, I open the ticket, I see what are the requirements for that feature that should be implemented or fixed, and then I jump to the tests. So I understand what the end result should look like, so that I can give valuable comments for the actual implementation, right? What does a good test look like? I was thinking a lot on why do some people think that tests are useless, and I found no answer that they just have the bad experience with tests. They just been to the projects where the green pipeline means nothing, where after refactoring something you break the tests and so on. They've been to the projects where you see the green light, but you're like, ha, yeah, of course. So let's talk about a good, solid set of tests and how should it look like. let's talk about basics. Good tests protect against regression. Regression is a software bug when after modifying your code base or adding a feature, the remaining functionality stop working. And that's a very bad situation to be in. And you can imagine that more features you develop, the higher is the chance that this kind of bugs will appear. The bigger is your code base, the higher is the chance that there will be the errors. And that's actually the place where the microservices can help. If they build right small, the bugs just won't have much places to hide. If we talk about the protection against regression, we can clearly say that the bigger is the amount of code that is being executed during one test, the higher is the chance that that test will find some regressions in there. But it's not only about the amount of the code that is being tested, but also about its complexity and domain significance. And what do I mean by that? Not all tests are equally important, just as not all the production code is equally important. If you create like hundreds of test cases for some trivial code or for some infrastructure and boilerplate code, maybe you should focus more on the code, like where is like your domain logic and that there is a high chance of finding the bug there. And I don't mean that you shouldn't create tests for infrastructure and for boilerplate code, because if after updating your framework the application breaks, you are just as screwed up as if it was the bug in your domain code. But you shouldn't, go too deep into testing like trivial code first of all, and focus more on the valuable tests for valuable features where actually there is a chance to find the regression. Well, good tests are resistant to refactoring. We already talked about the refactoring, and let's imagine that you run the test, it's green, so you want to refactor. You go and change something, you run the test, it's red. You're like, no, that's impossible. You come back to the code to look for that mistake that you made. You go through the code with your eyes, you compile the code in your head, and everything is just like fine. And you run test, it's still red. Then you go and test that feature manually, and you see that it actually works, but the test is still red. That's called false positive. And that's a sign of a very bad test. That's a sign of useless test. And the main cause of that is the wrong test structure. Some people don't treat the tests as the part of the system, and that's actually the issue. You should apply, so all the patterns, all the clean code principles that you know and you apply to your production code, you should also apply to your test. And just as you decouple the modules in your production code, you should also decouple the tests from your code. So all this interfaces and abstractions, they should also be present in the test. And also very important, make sure the test verifies the end result that system delivers, not the steps it needs to do that, because that's the biggest mistake that people make when creating bad tests. Treat the test as some kind of black box. So you give the input, you check the output is right, so you don't check the steps that it needs to produce that output. And if you follow that, you will have a good test that will be resistant to refactoring. Good tests have fast feedback, and how to get the fast feedback? You must have fast tests. I've been to the project where we were writing only integration tests. And integration tests are fine. They give you the protection against the regression. The amount of the code that is being tested in one test is big. And it kind of gives you the resistance for refactoring. but the pipeline was like 15 minutes or something. And imagine you have to provide a quick hot fix on Friday, and it takes you like 3 minutes to fix the bug and then like half an hour to put the production. So of course you should always find that balance between, you know, resistance to refactoring, protection against regression, and the time that it needs to execute. So basically unit tests and integration tests, we all know the testing pyramid, right? And usually we know it's as a pyramid with the length of each block as the amount of the tests that should be of that type. But I would say that in most of the projects, it's not a pyramid, but more like, you know, some like boxes. So we would have like the same amount of unit tests, the same amount of integration tests to find that balance. Good tests are maintainable, just as your code. Good code is maintainable, good test is maintainable. And this is important. Tests should be just as clean as your production code, if not even cleaner. Because if you give me the bad project with the good tests, I will be able to refactor it and make the project clean. But if you give me the project with the bad tests, and you know, I will end up in fixing both production code and the tests and so on. So again, everything you know about the clean code, all the principles, namings, and so on, you should apply it to the tests as well, and they also should be easy to run. I mean that in order to run a test, you don't need to, you know, make some dance or like, you know, go reload database or something else. It should be just as easy as clicking one button or one method. And talking about the maintenance, let's talk about the anatomy of a good test. You all know how the traffic light looks like, right? So it can be different forms, shapes, but the anatomy of the traffic light is always the same. Like you have like red light, yellow, and green. So, and you recognize it, right? You wouldn't mix the traffic light with something else. And so the good, readable, and the maintainable tests should also be like that. They must have a good anatomy. For example, there is a pattern called 3A pattern. It stands for arrange, act, and assert. So in the arrange section, you should create, you know, all the objects, variables that you need for your test to run. Then there is act section, and if your act section is more than one line, or let's say more than one call, you should already ask the question whenever you build a test properly. And in the assert, there you can actually put like many different asserts and so on. What do you think? Is zero test coverage better than tests you cannot trust? I personally think that, you know, when you don't have the tests in a project and you are about to deploy something, you at least know that fact that you have some risks that maybe, you know, you would think twice before deploying that project to production, and maybe at least run some manual tests or something. And if you have the project where you have the tests, but you know they're kind of bad, and that green light means nothing to you, you're like, I have doubts, but the tests are green, so let's go. And also the bad tests will slow you down eventually with some time and give you not much value, I would say, and you will still need to maintain them, and they will also slow you down by like giving false positives or something like that. So I personally think no tests at all is kind of better than bad tests. And more on this topic, because, you know, it's just like 20 minutes presentation. I can't cover everything, but if you are interested into this topic, and I hope you are, I do recommend reading this book. This is called Unit Testing Principles, Practices, and Patterns. And if I had to pick up like one book, I would say this one is the perfect one. It's not so big actually, it's like 270 pages. We have it in the office, and it gives you all the basics that you need to know about the testing. Test-driven development by example from Kent Beck, highly recommended. and I recommend you read this book after you read the previous one. There is one more, The Art of Unit Testing. This one is more detailed than the first one. That's why it's also a bit harder to read. But it also has like very nice examples and insights. But again, if I had to pick only one book, it would be the first one. And the key takeaways. Remember about attributes of good tests. Remember about them, next time you write a test, you think about protection against regression, resistance to refactoring. You think whenever this test will be fast or it will slow down your pipeline. And whenever the code that you just the test that you just wrote is maintainable, or it's not clear for people who will come to the project after you what you meant by creating this variable or by structuring the test this way. The test as documentation, that's one of my favorites one, really. Like, you just go the tests, you see the examples. Highly recommended. Test code should be just as clean as your production code, if not cleaner. That's important. Tests are your best friends and they are not useless. All right, I guess we have no more time left, and we've got the next speaker, Oleksii, who will talk about Scrum. And actually, he's an Android developer, but he's also a certified PHP developer. So thank you guys, and
let's probably start. So software development is a hard thing, and managing software developers is even harder. There are some things which were invented to do this management thing. Who am I? Rather than engineering and development stuff, what I know about Scrum, right? Certified Scrum Master? No. So I just like to understand stuff and make people's life better and improve processes. So basically, yeah, I'm just a believer. Yeah, you can say like that. So if everything you hear here, take with a grain of salt. You can discuss some stuff with me, and it would make things even more enjoyable for us. Good. So how many people here heard about Scrum about? Wow. How many people used it? No. How many people understand it? Okay, optimistic. Okay, good. So let's just see the overview what it is. So we have some things, and I actually like Scrum. Many people say I would just remove, for example, dailies. I mean, I hate them. I mean, they are useless. We don't do many things there, and we update some stuff which we know every day. I would also remove this sprint retrospective, because it's kind of also just a meeting about meeting, and we don't use outcomes. And then I would just remove whatever, planning, because why do we need to plan some things if we just can take things from the top of the backlog and it would be fine, totally fine, right? We can also remove some reviews and the backlog itself, because we have product backlog, right? It would be totally fine, probably, right? But is it Scrum at this point? And what is this about? Why do we even care about managing stuff if we can just code, deploy, code, deploy, code, deploy? What we really want as a developers usually, we want to do important things, right? So we want to create some value, probably. If you don't do value, why are you going to work, right? If you don't do important, if you do unimportant things, if you just fix bugs, is it what you want to do? If you are doing stuff which no one needs and you are not adjusting, again. So basically, all these things which we want to have and enjoy our work, it looks similar to some kind of agile stuff, which is today, in today's a swear word maybe for some people. But many people hearing about the agile, they don't really understand what it is about, right? So let's just do a quick overview. Agile is predictable, right? So we can predict whatever outcome is. it's rigid. We can have results anyway, and we can control the outcomes, right? No, probably. So agile is agile, right? So we are living in the world where planning, strong planning for a long time is just impossible. That's why some time ago, last century, people gathered and decided that we can do better and we need to do better. And that's why Agile Manifesto appeared. And basically, all these principles, they explain that actually we do things for people, by people, basically. And interactions between people are more important than some formal things. And that's why we actually do what we do. We create a value for other people, which are our users usually. One of the principles, we have motivated individuals, and we create environment for them, we support them, and we trust them to make their job done. A lot of this explains why we do our job every day. And if we don't have that, then probably we chose the wrong team, wrong path in life. I don't know. If we don't have motivated people and we don't have environment, we cannot really do things in agile style. Basically, we don't have prerequisites for the things to be flexible. If Scrum is agile, why is it so bad sometimes? So yeah, there is basically two main components. One is the lack of trust by the management in developers. And the second is basically problems like demotivated people who are overly controlled. When the management gets things only about business, money, they try to overly control the process, and it breaks basics of the agile development itself. And basically, we have the situation when this loop gets perpetuates, and we have management trusts less. Developers do worse job because they don't have enough freedom to make decisions. Basically, Scrum works the best when people understand what they are doing and why. So if people don't have high-level understanding of the process and the knowledge of not only part what they do, they don't just do some task, move tickets in Jira from one column to another. If they don't understand the whole process, if they don't have flexibility and power to adjust these changes, if they don't have enough power to take important decisions on the development itself, then they basically get demotivated. And if you have all these things, basically, yeah, Scrum works well, but anything works well. So basically, it's again about people, for people, from people. And it's not about Scrum, it's about any process. So what could be done to improve? Many people, they don't take enough responsibility and they don't have maybe motivation to own the process. And that could be one of the factors why people think that these management tools are bad, because they are used in a way that was not designed for development, basically. So if you want to make it better, basically it's up to you to raise a voice, make it work for your team, your company. And if you don't have such powers, sometimes it's much easier to change a team, for example, rather than, for example, to overcome some very powerful manager who does not allow team members to do things. And yeah, be respectful when you try to change something. sometimes it gets hard not to like break something or like make a personal damage in communication. So yeah, that's very important. Also, that happens that in your team specifically or in your company, Scrum just doesn't work because it was created for specific team setup. It was created for specific projects. It was created in a specific process in mind. If you don't have a cross-functional team, probably Scrum wouldn't work because iterations need to be done regularly by all members of the team, not just one platform or one side. People think that about like anything, like let's say you have a hammer, everything is a nail for you. So Scrum is not a silver bullet. It will not fix all your problems if you have bad communication, if you don't understand what you are doing, and so on. And sometimes, again, it's better to choose something else, but you should be careful and just learn from past mistakes, because even in the Scrum specifically, some processes, they were created with some experience, and they did their mistakes already. If you want to do something what you want, you just need to learn first from past mistakes before you add something or change something. Sometimes management just for management is also like happening, and yeah, you need to think about your users and why you are doing things you are doing. And sometimes easier process and faster delivery and faster feedback means more than regular meetings and or some specific processes. Yeah, let's quickly sum up what was said. So yeah, don't forget why are you here. Like, users are the most important why you are here, and the value created for the user regularly is the most important stuff. Yeah, share knowledge, communicate. The best way to transfer knowledge is face-to-face communication, and like no documentation will solve this kind of gap between people. Yeah, be trustworthy. If you committed to do something, do it please, and expect from others, do something without overly control them. If you are not enjoying what you are doing it wrong, and if you cannot change, you try, you fail, change something in your company, maybe you can just like try to escalate if you cannot do anything. Like, if you are not enjoying, then probably you can rethink this setup, and probably sometimes the best way or easier way to change something is to, whatever, I don't know, to change team inside a company, sometimes to change the company. There are some resources. I highly recommend to download Scrum Guide in your language. Read it. It's very, very simple and short. It is not a Bible. Please don't think of it as of some kind of absolute knowledge. There is no absolute knowledge in this world, and Scrum Guide is also not an absolute knowledge. But knowing what you are doing and why you are doing is very important. And if you just trust or believe people, sometimes it creates a miscommunication. Yeah, Agile Manifesto is super interesting, and I also recommend to read it. It's like one page. Yeah, that's it. Thank you. Our next speaker, Dovydas, would tell you about the applied security and cryptography. So yeah, welcome.
So my name is Dovydas. I'm a Guild Tech Lead, backend Guild Tech Lead at NordTech. So I've been a developer for some time. I'm also from Lithuania, and to have a small talk afterwards, I'm gonna say my hobbies, which is football and animals. And I also have a corgi, so yeah. So I think we can start, and this is the agenda. So we're gonna go through cryptography algorithms and functions. Then we'll talk about the SSL certificates a bit. And then I'm gonna talk about authentication and authorization and the usage of cryptography in practice. So these are the main cryptography algorithms and functions. I'll shortly talk about every single one. So starting hashing, most of you probably know, but it's a process of transforming data into another value without the possibility to retrieve the original data. It's mostly used to compare data without actually knowing what's inside of it or storing or without storing the original value. So examples could be, for example, password hashing, where you store the hashes of the passwords in the database, but you don't know the actual original values. Also, file checksums and etc. The next one is encryption. So it's a process where you also transform the data, but with the possibility to return it back to original value. So we have two types of encryption. First one is symmetric encryption, where the same key is used both to encrypt and decrypt data. And also we have a asymmetric encryption, where a key pair is used. So basically a public key and a private key. So public key is used to encrypt the data and private key is used to decrypt the data. So encryption is mostly used to securely transfer or store the information. We also have digital signatures, which is kind of an opposite operation of asymmetric encryption. So you have the message that you sign with your private key, and you verify the signature with the public key. And the next one is key derivation function, which is usually used to derive some kind of keys, secret keys from secret values. And secret value could be a password, a passphrase, or even another key. And the last one is the key exchange. So this is used to create a secure communications layer. So you exchange keys between multiple clients. So you know the basics of cryptography. What's next? So can you just jump in and start securing or using these algorithms? Maybe you already use them and you don't know about that, and hopefully you do. So the next thing I'm going to talk is the SSL certificates, which is Secure Sockets Layer certificates, which is in short just a standard to have a secure communication between a client and the server, or between two servers. And also we have TLS, which is kind of just a newer and more secure version of the SSL, but a lot of people still call it SSL certificates, because I guess it just became kind of the name for this technology or this standard. And also we have HTTPS, which just shows that the website is actually using this secure communication, and you can basically see in the browser more information about the SSL certificate and certificate authorities and etc. So why is it used and what does it do actually? So it is used, like I said, to secure the communication. And what it does, it encrypts the data between the two parties. So how does it work? First thing, I guess, as a developer, you would have to get a certificate from certificate authority and store it inside your server. So certificate itself contains of a public key and other information like certificate authority and etc. But also you retrieve a private key which should be stored securely in another place, and it should not be accessible to anyone else. So when I open the website and browser and I try to open this website which has the HTTPS protocol, what happens then? The first thing what happens is a handshake between the client and the server. So during the handshake, the server sends their certificate to the client, and the client validates the certificate with the certificate authority. If it is valid, and then what happens next is the client actually generates some random bytes which are encrypted with the public key which was inside the certificate of the server and sent to the server. So then the server decrypts the data and derives a symmetric session key. So both of these parties, the client and the server, have the same random data, the random bytes, which they can derive the same key from it. And this key is actually used for the network communication and encryption between the two parties. So we have the encrypted network. What's next then? So the next thing is authentication and authorization. So these are kind of different things and often are mixed up. So authentication also proves your identity, but authorization proves that an action is allowed or not. So these are a couple of examples of the authentication and authorization. So first one is basic authentication, which is just it's kind of an old concept, but I'm gonna still explain it. What happens is during every single request, you would have to add a basic authentication header, and that header would consist of base64 encoded username and password. So every single request, you would have to send username and password of that user. So this is, like I said, not really a secure way and kind of outdated and hopefully not used that much anymore. But yeah, the next one is the API keys. So usually either client or the server creates the keys and both parties store this. And once again, they are sent inside the header on every single request, or some version at least. It could be hashed and other algorithms can be used. So this is mostly used for server-to-server communication. And the next one is probably most used and most secure is OAuth 2.0, but it's also not only used for authentication, but also for authorization. So how does it work? Basically, when you are authenticating, you receive an access token. And this access token has some properties that help with authorization as well. So for example, TTL and scopes. So even if, let's say, the same user have different tokens, he can access different things. So for example, would be maybe with one token I can access API endpoints that are called from the mobile applications, and with another one I can access the admin panel endpoints. Is that enough? I would say that most of the websites have both of these, hopefully, but is that enough? So let's think about a case where my access token was stolen or leaked somehow. What can a bad actor do with that? Basically everything you can do. So get your information, update or delete your information, maybe even change your password so you cannot log in ever again. And let's say you are some kind of administrator of some kind of admin panel, then the user will also have access to other users, and maybe even they can block or delete other users, so they are the only person who can access that admin panel. So how can we solve this? One of the solutions is using digital signatures for request authorization. So once again, what are the signatures? So there's an example. So the example would be that Alice wants to send a greetings message to the Bob, and she sends the request with her private key. And Bob receives both signature and message, and he can verify with her public key that the message was not tampered with, and the person who is sending this message is actually Alice. So using this concept, we could add additional authorization to our websites, right, to our APIs. What would be the implementation and the process of adding it? The first step would be to generate a key pair. Usually, key pair generation is, we use cryptographically random functions to generate random bytes. And from that, we receive a private key. And the public key can be derived from the private key. So we have the key pair, right, on the client side. Where do we store it? So we have two choices here, locally and remotely, depending on the case, let's say, if we have a key pair per user, per device, or per session even, per client, we can have multiple. So it depends on the case where we should store that. But the most secure ways are secure storage. It could be keychain or encrypted database or encrypted file or anything like that. Also, if it's short-lived, we could use memory or even encrypted memory and other things. And to store it remotely, we have to make sure that the private key never leaves the client device as a plain private key. So then before storing it remotely, we would have to encrypt it. And encrypt it with what? So this is a big question. And this should be done with information only known to the user or to the device of the user. So this could be done with deriving a key from some kind of secure data, which could be a password or some kind of, like I said, information only known to the user. So then we could use this derived key to encrypt the private key before we send it to, let's say, a remote server, and then decrypt it after we retrieve it. So after we store the private key, we have to store the public key as well. And as the name tells you, it is public key. It's much easier to store it because you don't need to encrypt it. You can store it in the server, which will be validating the signatures. And you can even share it between other clients because it's, like I said, public. And the most important thing is how to generate signatures and what to actually sign. So you have to sign the message, but what the message can consist of and what are the advantages. So the first thing is the payload or the part of the payload. So while signing this, you make sure that the payload doesn't change when it's going through the network, right? From the client to the server. We could also use timestamp, which proves that the request was signed at that specific time, and the signatures cannot be reused between the requests. Also, we can use the other request information like domain, URL, request methods, headers, and etc. This also proves that the signatures cannot be used between different endpoints or different domains, and etc. Other authentication information or user information. And also, we can have some custom things like action or something like that, which has to be known both for the client and the server and shouldn't travel through the network. And pretty much everything else you can think of, and also a combination of these things as well. So the last part is actually validating these signatures and allowing these requests in the backend. So how the validation happens is first you have to build a message. It could be, like I said, just a payload or something like that. It could be a combination of some things you have to build. And then the public key of the client is used to actually verify if, like I said, the request is actually sent by the client and if it was not tampered with. So if it's valid and it's verified, then we allow and execute these requests. If not, then we block these requests. So this should solve one of the problems. Like I said, if, let's say, the access token was stolen, but if the private key was not, then the bad actor should not be able to do any harm without the private key. So the key learnings are that authentication and authorization are not the same thing. Like I said, it's often mixed up and it actually goes closely together, but yeah. Also, your system is probably already using cryptography, I would hope, even if you don't know about it. So for example, for password hashing and the SSL certificate and etc. And security also requires extra measures and extra work. And sometimes you have to even sacrifice some things like user experience and etc. I would say that security overall is kind of fragile and continuous topic, that even if you think today that your API is secure and has all the security standards implemented, maybe tomorrow it won't be. And I have one last thing I'm gonna end this on. When your API is secure enough. So I always give this example. When you have a door, how many locks do you have on it? You can have 1, you can have 10, but if you have all the keys to all the locks in the same pocket, it might not help. And also, someone might break in through the window. So thank you for listening.